Hello, everyone. Our presentation is automated playing of survival video games with common sense reasoning, and I'm Bryant Hargreaves.
My name is Dan Nguyen, and Keegan is not here today, and our principal investigator is Gupta, and we are undergraduate from the University of Texas at Dallas. So a bit of introduction. So this project is trying to autonomously play a survival video game that feature randomly but predictable generated event using common sense reasoning. And the reason we want to do this is to demonstrate that SCAPs and functional programming are effective tools to automate decisions in making actions to take based on random event. And so how do we do it? First, we collect the data from the environment, we convert them into predicate, and then we just use common sense reasoning to find possible actions and execute them. So
Okay. So a little context of our common sense reasoning is we're trying our best to simulate human reasoning and the choices humans would actually make. So we do that in three parts. So our first part being default rules with exceptions and preference. And so essentially when our first example is if you say you have a bird, right? Given no other knowledge about having a bird, you would assume that it could fly. But with as we all know, penguins are birds, but they can't fly. So to do that, we have default rules that say that something will fly if it's a bird, but if it's not an abnormal bird. And then we can later specify those rules saying that we have a bird Tweety, so we assume that Tweety flies, but we have a bird Sam, and we specify that Sam is a penguin, and so Sam cannot fly. And our next part is global constraints. So we have rules where there's an impossible choice. So we can't physically both sit and stand at the same time. And so we can say that's globally false and rule out that world. And so that brings us to our next part, having multiple worlds. We can have a situation where we have two professors, Mary and John, who are both professors and teach the database class, but John will be teaching if Mary doesn't teach a class, and Mary will be teaching if John doesn't teach a class. So in this scenario, there are two worlds where John is teaching and Mary is not, and the other one where Mary is teaching and John is not.
And so a bit background of the game Don't Starve. So Don't Starve is a survival video game. This is a gift. I don't know why this I'm playing, but it's a survival video game where players learn to survive in a harsh environment that are safe during the day and dangerous at night. And to survive, the player must carry out certain action that can affect their hunger, health, and sanity. And player can equip, store, and items to aid survival, like making torch during the night or making campfire during the night, cook some food to eat. And most items can be gathered, craft, and dropped from entities. So we call it Agent Wilson. Wilson is the first playable character that of the Don't Starve. There are multiple versions of Don't Starve, but this one is on feature like 10 unique playable character. And yeah.
Okay, so a quick overview of our agent. We have two main processes. One is the game modification, which interprets world data and sends it over to the server, which will convert the data to knowledge, combine the knowledge with rules, and essentially come up with the best action. And then we send that back over to the game modification, which executes the action and plays the game. Uh-oh. It's taking a second to load.
It's taking a second to load.
Yeah.
Okay. Okay. Just do next one.
Okay.
All right. Go next.
Same thing. I don't know, maybe it's...
Just do right here.
Yeah. What is that? Oh, which one?
Okay.
It doesn't like my image.
Just do this right now.
Okay, sorry. All right. So it doesn't like this picture, but it's a nice picture. Basically, the world is composed of multiple parts. There's a lot of different entities on the screen which we have to interpret and find out. And we want to take it from the perspective of our agent. Okay, we want to take it from the perspective of our agent so that it's only the same thing is viewed as a normal human. So we get parts like what part of the day it is, the day-night cycle. We have data about health, sanity, and hunger. We have the player's equipped items, the inventory, the entities on the screen. So that would be campfire, things on the ground, trees, pretty much everything in the game, and important information about each entity, like tags and characteristics. So a tree is choppable and flammable. Berry bushes are pickable and also flammable. A lot of things are flammable, so gotta be careful. Um, so yeah, this is our JSON data. It's a little hard to read, but maybe we can do it now. Okay. Perfect. Okay. So yeah, we essentially break things up into to parts, and so we have inventory. It's been condensed, so it's a little bit easier to read. You've got the GUID, the global unique identifier, and then tags about it. So whether it's can be used as a fuel source or it's collectible. And then you have is in light, so if it's not in the darkness, which is an essential part of staying sane. Other parts like health, sanity, hunger, other equipped and entities on the screen, and time of day.
Yeah, so with all that JSON data, we have to convert them into a predicate part. So like SCAPs can understand it. So you can see that we have the entity data. We convert them into like just like a predicate, just one fact at a time. Inventory, equipped items, agent status. You can see that sanity. We convert numbers into like words to make it easier for the rules when we try to do it. And the world characteristic. So time, is it day, night, or dusk, and how close it to the next cycle. So yeah, if you go back one more time real quick, so you can see there are some underline fact that we're gonna use. So item on screen is a evergreen, is a type of tree, and that tree is that tree is choppable, so you can use an axe to chop it. And currently, the agent is equipping an axe right now, and we know that right now it's occurring at daytime. And so yeah, this is one of the example rules. So I think in earlier slide we have like 22 rules and like 8 assumption that we made. So this is one of the rules. So there's an action at chop tree with if only it is choppable, and it is we have axe equipped, and there are not a lot of logs on our inventory, and the time is not night, so we can safely go around and test out. So yeah, this is the output of it. There should be more than one output, but like, and then we rank them. So like how we so in SCAPS, we just query all of the possible model, and it is like we order it in the SCAP program itself. So when we query them, the one that is above it will split out first. And yeah.
So once we get the best action back from the server, we then do a bit of actions. So these actions can include wandering around, exploring for other items, gathering resources, picking up twigs, berries, stuff from the ground. Cooking, so cooking at a fire, cooking your meat and food. Eating, staying not hungry. Um, Managing inventory, throwing out items that are you don't need because there's a limited amount of space in your inventory. Chopping trees, and crafting and building structures. So like workbenches, campfires, things that give you more access to more features of the game, which you get more data, more items as you progress. Um, so yeah, next is our demo.
So this is our demo right here. Just give it 1 second. So every time you make a new world, everything is different. It is randomly generated. So each world is different. And you can see that we are computing them in the background right there. And the big chunk of text is like the world data that we got. Okay, let's just run it for a bit. So before we continue on, would you want to guess how this agent die? Any guess? Yep. Starving. Good one. Any other guess? 3 falls on it. Any other guess? Losing too much sanity, which is terrible. Okay. Any other guess? It can be flammable. The agent can die from flames. Yes. All right. And let's do 2 more guesses. I think you can try. I don't know. I don't think so. Any other guess? You want to guess? There are monsters. Yes. What kind of monster you think is gonna kill the player? Like, guess a random monster. Okay. Sure. Okay. Close enough. Close enough. Okay. So you can see that they are chopping trees right now to get some logs. Yeah, and then like right here. Okay. So it's like this is the dusk time right now. Um, and I think I will show you the night. Oh wait, this is morning again. It did survive for 50 minutes, which is day 7. It survived to day 7. It's just like the guy that we follow only go up to day 7, so we just like trying to make rules that based on that guy to give new players. So you can see that during the night it's like empty dark, so it can build campfire to survive the night and everything like that. And it cook berries too. You can see that they cook some food also. Yeah. So let's see how it die real quick. I think the monster, yeah, the monster chased him for like 1 whole day, I believe. Yes. So like if it chase you, so like how we got it, so if it chase you, just run away. We don't try and like, attack it right now. So if it chase you, just run away for now. Yeah. You can trap them or you can beat them with a sword.
They're friendly monsters also.
They are friendly monster too, but
Yeah, let's skip a little further.
so it survived to day 7, I believe.
Sorry if I missed this.
Yeah.
Is there like tick? Like how often does the logic run?
It ran every time there. So like I think it run like almost every time there is an action. So like it can be actions, it run immediately right away. It's only one loop. There you go. You can see there's a tree monster that's chasing the thing. And so you can see that it's night, right? And the agent know that you cannot survive in the dark. So it used a torch to escape the monster. And yeah, we didn't expect a tree monster. Oh wait, it did survive to that day. Oh yeah, there you go. It just chase you. uh, yeah. There you go. It finally died from the tree monster. Yeah, and just continue with our presentation. Just a few more. Yeah, click on it. Oh, wait, what? Okay. So yeah, so this is some statistic. Um, we did 8 runs. The first run is due to darkness. I think it just wandered around the savannah, and there's nothing in savannah like trees or bush to make campfire or torches, so it just died in darkness there. And they did die from like out of sanity too, which is terror break. I think someone said earlier, but it died a lot to hostile mob and starve hungry. So it did starve, sadly. Yeah. So here's the conclusion.
Right. So in conclusion, our agent was capable of using common sense reasoning to somewhat mimic the wiki guide for a beginner player. So, um, so yeah, it was able to survive roughly 7 days, given that it was able to outrun several hostile mobs. Um, and so yeah, we were able to model this reasoning with SCASP predicates and survival strategies and make context-aware survival decisions. So running away when necessary, making food, eating food, staying alive from fairly understood surroundings, I guess. And so some challenges we faced were specifics on threat distances, right? So once the entity left the screen, so when the player ran away from the tree and got far enough away, it would forget about the tree monster. So, and the tree monster will catch up, and then, so there are quite a few other things. So optimal resource collection, right? So in a savanna, we run out of resources, and intuitive human strategies, right? We can definitely model a better reasoning strategies there. And so future work would be to make better planning, better resource management, and resources, tools and building structures, and incorporate some sort of better memory mechanism to remember things like further away, where you are, and other resources. So.
Also, the thing about this game is also wiki intensive. So like you have to read the wiki to understand how to play it properly. So yeah. Yeah. So thank you. My name is Nguyen again.
Yes, I'm Bryant Hargreaves.
So the issue with object permanence and forgetting about the monster, does the agent keep any kind of memory of like where important resources were, or like are there laws of inertia in the program, or is it just what's on the screen is what it knows about?
It's like outside, out of mind. So yeah.
It does remember the previous action.
It did remember the previous action though. So like it's like we so like how we compute the action is that as soon as we done computing, we compute again and again. So we ignore the we don't wait for until the action is done. So it have to remember the previous action, and if we still doing it, then we ask them to continue doing it. Yeah. So that's the only memory we have. But like if it's outside, it's out of mind. So.
Hi, thanks for the presentation. It's very great. I was wondering how it prioritizes between like different needs. Say if like it's hungry and it's like also low health. Like how does it prioritize between these two, or like sanity wise?
So right now it doesn't prioritize. So like we prioritize it in the code wise. So like we can reorder the rules. So like how we compute we compute all the rules at once. So if we put the rules earlier, the earliest rule will get output first, and then it's gonna go down and down and down. So we just take the previous row. But like we also have memory, so we compute everything to ensure that the previous action is we still doing it the previous action. So we need to continue doing it, because like chopping trees require like times. You cannot just like chop once and it's gonna get you logs. But yeah. Any other question?
It is just a kind of a technical question regarding the whole environment. How is the information about the world provide? Did you have to implement that, or is the game providing some mod interface that has this JSON output that facilitates all of the interaction?
The game is very developer friendly, so it has a lot of uh, scripts and stuff made available for modifications, mods. So a lot of the things that we find are purely available from the base Lua code. So the Lua world, we can get entities from everything. The hard part was parsing those and getting all of those into a format that we could move over to Python and then SCASP. So, which we did by parsing into JSON. So just to make it easier and more readable. Thank you.
Thank you so much.